Okay, picking up where we left off last time, we're going to talk about the determinant and the inverse of a matrix. So first of all, the determinant, only square matrices have a determinant. The determinant of a matrix is a scalar, and we'll see it has some uses later on. But we can do a 2 by 2 and a 3 by 3 by hand pretty easily. First of all, the designation of a determinant, we show it in the absolute value brackets, or just det of A. And so let's look at a 2 by 2 first. Here's a matrix A. To find its determinant, we cross multiply. We take the product of the values on the diagonal and subtract the product of the values on the off diagonal. So, pretty simple to do. Take the determinant of this matrix. It's going to be 5 times 1 minus 4 times 3, or in this case minus 7. For this one, 6 times 1 minus 3 times 2 is 6 minus 6, so that determinant is equal to 0. For a 3 by 3, it's a little more involved, but we can still do it by hand. And in fact, we really need to. There's some things that you do in statics that really lets you, really requires you to do this determinant by hand. So the way we do this is to break it down. We'll use the top row here. And so the first term is going to be A11 times a 2 by 2 determinant. And that 2 by 2 determinant is of the small matrix that would be made by marking out the first row and the first column. So what we're left with is A22, A23, A32, and A33. The second term is negative, and it's going to be A12. And again, the 2 by 2 determinant is of the matrix that's left if I mark out the first row and the second column of the 3 by 3. And the third term then involves A13, and again the determinant of the 2 by 2 matrix that's made by marking off the first row and the third column. Now, you can do this with larger matrices as well, but we'll use MATLAB or Excel to do that. So here's a 3 by 3. And so to expand this out, the first term is going to be A11, which is 2, times the determinant of the 2 by 2 matrix 5214. The second term involves A12, but remember that's got to have a negative sign, times the matrix 4234, the determinant of that. And since A13 is 0, that third term will be 0. So in the first case, our determinant of a 2 by 2 is 5 times 4 minus 1 times 2, or 20 minus 2. For the second one, that determinant is 16 minus 6. And so we break that down to the final answer. And again, the determinant is always a scalar, and in this case, the value is 26. Now, I'll skip over some of the math of this. If you want to work through it yourself to check it, then pause it right here. There we've expanded it out based on the elements of the first row. Do the calculations, and in this case the determinant of that matrix comes out to be exactly 0. Now let's move on to talk about the inverse. Not every matrix has an inverse. First of all, it has to be square, but even then some square matrices do not have an inverse. However, if that matrix exists, then we multiply a matrix by its inverse. What we end up with is the identity matrix. Again, a square matrix, 1's is the diagonals, 0's everywhere else. So it is possible to find the inverse of a 2 by 2 or a 3 by 3 by hand. We're not going to emphasize that, but here's the formula for that, and I'm just going to work through these pretty quickly. Notice the determinant is in the denominator here, 1 over the inverse. So we found the inverse of that little matrix is 10, and so the inverse is 1/10 times, and notice we've switched around the A11 and A22. A11 and A22 switch places. The diagonal elements become negatives, and so there is our inverse. Now we can check that simply by multiplying that matrix by its inverse, and yes, we do end up with the identity matrix. So again, don't worry too much about the calculations here. We'll do these with MATLAB and Excel. But if you do this one, again, you can check and make sure that when you find the inverse, if you multiply it by the original matrix, you get the identity matrix. Now you can do a 3 by 3. Again, we're not going to do any of these, or you're not going to have to do any of these by hand, but here's what that all boils down to. Now, one thing I do want to show you here is that just like with the 2 by 2, the determinant of the matrix is in the denominator. It's 1 over the determinant times some stuff. And so again, I'll skip over the numbers of this. And again, you'll see that when I multiply the inverse times the original matrix, I do end up with the identity matrix. Now you notice those formulas that I tried to point out, that the determinant is in the denominator in both cases there. So if the determinant is equal to 0, then we know that the inverse is undefined. Now again, that held for a 2 by 2 or 3 by 3, but it is true generally. So if we have a square matrix and the determinant is 0, then that inverse does not exist. But if the determinant is non-zero, then there is an inverse, and we'll also show that that is unique. That is, that there's only one inverse to the matrix if it exists. And so next time we'll look at how to do these matrix operations we've talked about in MATLAB, and then we'll follow that up with doing them in Excel.